When astronauts aboard Apollo 17 looked back at Earth in 1972, they saw something breathtaking, a shimmering blue sphere suspended in the black emptiness of space. Water covered over 70% of its surface, earning Earth the poetic name the Blue Marble. It's our planet's most defining feature, essential for life, climate stability, and geological processes. But there's a bigger question lurking beneath the waves. Where did all that water come from? This isn't a trivial question. Water, made of hydrogen and oxygen, might seem simple, but Earth formed in a region of the early solar system that was too hot for liquid water to survive. In theory, our home world should have been a dry, rocky wasteland. Yet here we are, oceans, lakes, rivers, and clouds abound. The mystery of Earth's water has fascinated scientists for decades, and the answer takes us billions of years back, deep into the violent and chaotic origins of the solar system. Chapter 1. The Dry Birth of a Wet World. Let's travel back 4.6 billion years, to when the solar system was just forming from a giant cloud of gas and dust, the solar nebula. At the center, the sun ignited, blasting heat and solar wind into the surrounding disk of material. Closer to the sun, in the so-called snow line, temperatures were too high for ice to exist. This is where Mercury, Venus, Earth, and Mars formed, the rocky planets. Beyond the snow line, in the colder reaches of space, ices could survive, and giant planets like Jupiter and Saturn formed surrounded by moons rich in frozen water. Earth formed inside the hot, inner zone. The materials that clumped together here were silicates, metals, and minerals, not ice. Early Earth was molten, pummeled by asteroids, and constantly losing lighter molecules like water vapor to space. This is why the puzzle is so intriguing. If the building blocks of Earth were dry, how did our planet end up with oceans deep enough to drown Mount Everest? Chapter 2. Theory 1. Delivered by comets. One of the earliest and most popular ideas was that comets brought the water. Comets are dirty snowballs, chunks of ice and dust from the cold outer solar system. If a swarm of them bombarded early Earth, they could have deposited huge amounts of water over millions of years. The logic made sense. Comets are rich in frozen water. They travel into the inner solar system and occasionally collide with planets. But there's a problem. Scientists can analyze the type of hydrogen in water, specifically, the ratio of deuterium, heavy hydrogen, to normal hydrogen. This acts like a fingerprint. When researchers compared Earth's ocean water to the water in many comets, the match was off. Most comets have a higher deuterium ratio than our oceans. In other words, comets alone couldn't have been the main source. They may have contributed, but not enough to fill the oceans. Chapter 3. Theory 2. Asteroids as cosmic water trucks. If comets weren't the main delivery system, what about asteroids? Asteroids from the outer edge of the asteroid belt, called carbonaceous chondrites, are rich in water-bearing minerals. These minerals trap water in a chemically bound form, protecting it from evaporation. Around 4 billion years ago, during a period known as the Late Heavy Bombardment, the inner planets were pelted with countless asteroids as the orbits of Jupiter and Saturn shifted, flinging debris inward. When scientists measured the deuterium ratio in water from certain carbonaceous chondrites, it matched Earth's oceans almost perfectly. This is a smoking gun. Asteroids likely delivered most of Earth's water. This theory also explains why Earth's water didn't just boil away in the early, hot days. It arrived locked inside minerals, released slowly over time through volcanic activity. Chapter 4. Theory 3. Born from within. But what if Earth's water didn't all come from space? Another compelling idea is that some of it was here from the very beginning, trapped deep within Earth's mantle. Even in the hot, dry zone of the early solar system, hydrogen from the solar nebula could have bonded with oxygen in Earth's minerals, forming water locked inside rock. Over billions of years, volcanic eruptions and plate tectonics could have released this water to the surface, creating the first oceans. Recent studies of ancient minerals called ringwoodite, found deep in Earth's mantle, show they can hold significant amounts of water, potentially 3 times the volume of all surface oceans. This hidden deep water reservoir suggests that part of Earth's water cycle is internal and ancient. Chapter 5. The violent delivery. Whether from asteroids, deep mantle, or both, the journey of water to Earth wasn't gentle. Early Earth's surface was hellish, molten rock, constant meteor strikes, toxic gases. When icy asteroids or comets hit, the impacts were so powerful they could vaporize rock and melt crust. And yet, because the water in asteroids was trapped in minerals, not free ice, it could survive these impacts, later being released slowly through volcanic outgassing. This process also helped form our first atmosphere, which trapped heat and allowed liquid water to remain stable on the surface. By around 4.3 billion years ago, Earth likely had enough liquid water to form shallow seas, even while asteroid impacts continued. These oceans would become the cradle for life.
Thanks for watching, and subscribe for the more video.